Hey guys, this is our very first lesson of Unit 3, Parent Functions and Transformations. We're really getting into the meat of Algebra 2 now. We're going to be taking a look at different types of function families in which each function family has something called a parent function. And a parent function is just the simplest form of that function family. So we're going to look at graphing absolute value equations and inequalities today. And our objective is to graph absolute value functions using a table and to graph absolute value inequalities. So the first thing we're going to take a look at is the parent function of the absolute value function. And the parent function, again, is the simplest form of the absolute value function, which is f of x equals, and remember this is just the same as y equals, f of x equals the absolute value of x. Okay, so again, this is the simplest form of the absolute value function. And so we're going to take a look at the graph of this function. And so if I was to graph this, I would complete a table of values, and then I would plot the values on the coordinate plane. So I'm going to go ahead and make a table. And I'm going to number it -3, -2, -1, 0, 1, 2, and 3. And I'm going to evaluate the function I'm going to plug all of my inputs into the function for x. And so actually, let's label this column instead f of x, which just means if I evaluate for this value for x, what do I get? So if I plug in a -3 into this function, I would get the absolute value of -3, which is 3. If I plugged in a -2, I would get the absolute value of -2, which is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of +1 is 1. Absolute value of +2 is 2. And the absolute value of +3 is 3. Notice this pattern here. It goes 3, 2, 1, 0, 1, 2, 3. This point right here has a specific name. This is called a turning point. Another word for turning point is vertex. And so now we're going to take a look at the graph of this function. And so I'm going to use these little coordinate planes that we talked about in class, and I'm just going to graph each of these points. So starting with -3, +3. I'm going to put a point there, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Then I'm going to connect the dots to form my graph. And if you take a look, it makes the shape of a V. Now remember, the absolute value means distance away from 0, and so all of these points have a corresponding point that is the exact same distance or the exact same rise over run away from 0. We have the exact same slope on the right as we do on the left. Now if we take a look at the domain and range of this function, our domain, all of our x values, so if I look from left to right, on the left I have an arrow. And so that means that this function is going to continue moving to the left towards -infinity. Then if I look on the right, I have an arrow as well. And so that means it's going to keep moving to the right to +infinity. Then for my range, I'm going to take a look bottom to top. So my lowest point here is at 0, 0. And so the y value for this would be 0. I'm going to use a bracket because it includes 0. And then my highest value, well, we've got these arrows that are pointing up, which means this function continues on to +infinity. Now, some things to note again about absolute value functions is that absolute value functions form a V. Think of V for absolute value. They form a V shape, and the turning point is called the vertex. Alright, so we're going to write down some steps to graphing all kinds of different absolute value functions. Again, this one that we took a look at so far, this is the parent function. So this is the simplest form of the absolute value function that we're going to see. And we're going to take a look at steps to graphing other types. So steps to graph. So step 1, you're going to find the x value of the vertex. In order to do that, you're going to set the expression from the inside of the absolute value bars equal to 0. Whatever's inside those absolute value bars, set it equal to 0 to find the x value of your vertex. Then, step 2, you're going to place this value in the middle of your table. In the center row of your table. You're going to number your values up and down to complete the table. And then the last step is to graph. That table is going to give you a set of ordered pairs that you can graph. So taking a look back at this example, if I was to set the inside of this equal to 0, I would get x equals 0. And so we place that in the middle of our table. Then we number up, so I went up each unit, and I went down 1 unit. We plugged all those values into our absolute value function to get our output. So we have an input, we have an output. Those represent ordered pairs. We placed all of those ordered pairs on our graph, and we connected the dots to form our V-shape. So let's take a look at another example. Let's say we have something like this. F of x equals the absolute value of x minus 4. Okay, so the first thing we want to do is find the vertex. So we're going to set the middle, so this x minus 4 equal to 0. So whatever's in the middle, we set equal to 0 to find the vertex, and we're going to solve. So we add 4 to both sides, and we get x equals 4. So this is going to go in the middle row of our table. So place in middle row. So if I make a table of values, I have an x column, and then I have my f of x column. So I'm going to place 4 in the middle, and then we want to number up and down. And I'm okay if you just number up 2 and down 2. So 4, 5, 6, and then 4, 3, 2. Now we're going to evaluate our function for each of these x values. So if I plug in a 2, I will get the absolute value of 2 minus 4, and that would be negative 2, which would become a positive 2 for absolute value. If I plug in a 3, I would get the absolute value of 3 minus 4, which would be negative 1, which the absolute value is positive 1. And then I would keep on going and plugging these in. So the absolute value of 4 minus 4, well, we get 0 for that. The absolute value of 5 minus 4 is a 1. Notice now that turning point. After that turning point, I'm going to see this pattern. Their numbers were going down, and now they're going to go back up. Absolute value of 6 minus 4 is 2. Now I have these inputs and outputs that I can plot on the same coordinate plane. Alright, so after I create the table of values, my last step is to graph. So now, I'm going to take these ordered pairs and plot them in the coordinate plane. All right, so now I'm going to plot all these ordered pairs. So 2, 2, 3, 1, 4, 0, and then that's our turning point, 1, 1, or excuse me, 5, 1, and 6, 2. Now I'm going to connect the dots to create my absolute value graph. All right, let's try another one. F of x equals 2, or the absolute value of 2x plus 6. Okay, so the first step, you want to take the inside of the absolute value bars and set it equal to 0 and solve. So 2x plus 6 equals 0. So we're going to minus 6 from both sides. And we get 2x equals negative 6. Divide by 2. And we get negative 3. So x equals negative 3. That's the x-coordinate of our vertex. Now we make a table and we place that in the middle row of our table. So our x values on the left, and then our output, or f of x, on the right. So middle row is the negative 3, and then we want to number up and down. So negative 2, negative 1, and then negative 4, negative 5. Now we're going to evaluate the function for each of these values. So if I plug in a negative 5, I would get 2 times negative 5 plus 6, which gives me a 4. 2 times negative 5 is negative 10, plus 6 is negative 4, and the absolute value is positive 4. Then I want to plug in my negative 4, so 2 times negative 4 plus 6. 2 times negative 4 is negative 8, plus 6 is negative 2, the absolute value of which is positive 2. Plug in the 3, so 2 times negative 3 plus 6 will give me 0. This is my turning point here, so I can expect this pattern to now, it was going down 4, 2, 0. I can expect it to climb back up now, 2 and 4. So let's see. 2 times negative 2 plus 6. 2 times negative 2 is negative 4 plus 6 is positive 2. And then the last one, 2 times negative 1 plus 6. Negative 2 plus 6 is 4. All right, now that I have my table of values, I'm going to graph this absolute value function on the coordinate plane. Okay, so negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 4, 2. Negative 3, 0. Negative 2, 2. Negative 1, 4. And then connect the dots. All right, next we're going to take a look at absolute value inequalities and how to graph these. We have to remember some of the rules about whether it's a solid line or a dashed line, and we're going to have to do some shading. So I'm going to set up the next page of notes, and we're going to take a look at inequalities examples. Okay, so graphing absolute value inequalities. Same steps apply when you're graphing just absolute value functions. First, you want to make a table with the vertex in the middle. Then you want to recall the rules about graphing inequalities. Okay, so our rules. When we graph, we want to use a dashed line for less than or greater than, and a solid line for less than or equal to, or greater than or equal to. Then we shade. Shade above the graph for greater than or equal to, and shade below for less than or equal to. All right, so let's look at an example. Let's say I have f of x is less than the absolute value of x plus 1. So we follow the same steps when we graph just regular absolute value functions. We're going to take the inside of our absolute value expression here, whatever's between the bars, and we're going to set that equal to 0 and solve for x. And remember, that gives us the vertex. So solve for x, subtract 1, you get x equals -1. Now we're going to place this in the middle column of our table, or the middle row of our table. So we have a table x and then f of x. Place -1 in the center, number up and down. So -1, 0, 1, -1, -2, -3. Now we're going to evaluate the inequality for this. So if I plug in a -3, we get -3 plus 1, which is -2, which the absolute value is +2. When I plug in a -2, I get a 1. When I plug in a -1, I get 0. When I plug in a 0, I get 1. And when I plug in a 1, I get 2. Again, this is our turning point, so we should see this pattern where it goes 2, 1, 0, and then it climbs back up 1, 2. Now we're going to graph this and recall the rules for graphing inequalities. So we're going to take a look at that inequality symbol, and it's less than. So if the symbol is less than, it's not equal to, then we're going to use a dashed line. So this means dashed line. And since it's less than, we're going to shade below. So plotting this, we've got -3, 2, -2, 1, -1, 0, 0, 1, and 1, 2. Dashed line because it is less than. If it was equal to, then we could use a solid line. And then it's less than, so we're going to shade below. So everything below this inequality, where y is going to be going down. We're going to do one more example of an inequality, and that is all for these notes. I would like you to try this one on your own, pause the video, and then press play when you're done and see how you did. I would like you to graph the inequality f of x is greater than or equal to the absolute value of 2x minus 12 minus 7. Now just because we have this value being subtracted at the end does not change our steps. We still want to set the inside equal to 0 to find the x coordinate of our vertex, and then plug in the x values and evaluate the entire function for each x value in our table. Okay, so again, you're going to set that inside of the absolute value bars equal to 0 to find the x value of the vertex. So 2x minus 12 equals 0. Add 12 to both sides, and we get 2x equals 12, divide by 2, x equals 6. That is the x value of the vertex, and that is now going to be placed in the middle row of our table. Okay, so 6 goes in the middle. We number up and down, so 7, 8, and then 5, 4. And now we're going to evaluate the function for each of these values for x. So the absolute value of 2 times 4 minus 12, and then minus 7. Okay, so when I do that, 2 times 4 is 8, minus 12 is -4, the absolute value of which is +4, minus 7 is -3. And then when I plug in a 5, the absolute value of 2 times 5 minus 12 minus 7, and we get -5. When I plug in a 6, 2 times 6 minus 12 minus 7 gives us -7. That is our turning point right there, and so we're going to see this pattern, -5, -3. Now I'm going to graph this inequality on the coordinate plane by plotting all of these points and then considering that inequality symbol if I should have a solid or dashed line. So 4, -3, 5, -5, 6, -7, 7, -5, and 8, -3. All right, now looking at our inequality symbol here, it's going to be a solid line. So we'll just connect the dots like normal. And it's greater than, so we're going to shade above. So that's all of this above the line. Now if this line extended, we would kind of have this boundary right here. So everything above would be inside the V. All right, that's all for today's notes. Tomorrow you'll be practicing graphing absolute value functions and inequalities. And on your practice, it is going to give you a table for you to fill out as well. So please bring any questions with you to class tomorrow, and be sure you're filling out the summary sections for your notes.